at the beginning, last class, I showed you this diagram. This is sort of the big picture roadmap of the whole entire course. So the red box on the bottom is kind of what we're talking about today. And as I talked about last class, that's sort of the foundations for really everything in the class. So that's kind of also why I had you do the that self-assessment. I was curious to see, on these pathways where some of you have gone. Some of you self-identified you're experts at Unity while you've never heard of ArcGIS Online, versus some of you said you're really comfortable with ArcGIS Pro, but you've never done, say, Unity, right? So we're kind of trying to build everything up, okay? So there was a video you were to have watched before class. I didn't have any kind of assessment to ensure that you watched it. So you're on your sort of own honor if you actually had watched it. But we're going to go through the content of that video with some hands-on things. So here's what we're hopefully going to learn today. Some core GIS software concepts. And we're going to actually hopefully have it work fine. We're going to open up ArcGIS Pro software. But today is not really a session on ArcGIS Pro directly. I'll show you a little bit just to kind of navigate around some data. But really I'm using that to show you about these topics: map projections, coordinate systems, data models, some basic mapping concepts, and cartography ideas. And this is really, again, like I've said, this is the roots of everything we're going to be doing this semester. And I'll try to show you with some select examples how what we're talking about feeds into some of the more specific topics as we go along, okay? So to start with, let's go get, I want to make this hands-on and interesting. I mean, I'll talk a lot, but what you can do is go back over to my courses, and hopefully this will work for us. We're going to go down this file right here, L1B package. 8.9. So you're going to go ahead and download this and put it somewhere where you can find it easily. Like I'm going to put mine right in, for today, I'll put it right at the root of, this is a folder on my system where I keep all my teaching for this class. I'll put it there. Okay. Now, what this is called is it's an ArcGIS Pro project package, and if everything works correctly, I did test it out, but you never know until you try it. It has the data sets from that video I assigned before class kind of packed up to open in ArcGIS Pro. So if I go here and just click on it, ArcGIS Pro software should open up. Okay, so go ahead and do that. Download it onto your system. And there may be some things to kind of go over to make it, but that's what you should see. So let me just pause my screen recording for a second. Okay, so back to my screen recording. So if you're watching this video, we have some data sets in ArcGIS Pro that we're going to use to talk about these GIS concepts. Now, for what we're doing today, like I said, we're not going to really go into much about ArcGIS Pro as a software, but just some really basic things we'll do today. This is obviously the map. If you move your mouse on the map, if you've never seen this software, hold your left button down, and that'll be a pan operation. When you have up here it says map and then explore. Okay, and they've got this thing where they give you a little a visual help tooltip. It's very similar kind of interaction like you get with Google Maps. Okay, so so if I hold my left button down, I can pan. If I use my, if you have a wheel on your mouse, you can zoom in and out. Okay. And then the other thing, really that's all we need to really worry about for today. If you go over here, over on the left where it says contents, and then there's vector raster. If you were to uncheck where it says raster, that'll turn that image off. If you go to the drop down, there's a little triangle right here. This is what's called a group layer. And if you turn that on, if you check things in here, you'll see various data sets. And this is basically like I always tell students, if you ever use tools like Adobe Photoshop, It's the same kind of idea, a layering of things in your view. So that's the basic concept here. So like if I turn that on, you'll see these other things kind of start to show up on the map. And then I'm just using the checkbox to toggle their visibility, okay? And then if I scroll all the way down, I have this OpenStreetMap. If I turn that off, nothing. So you can play around with those things, you know, while we're talking here and so forth. All right, everybody good with that? I mean, that's really rudimentary operation, but if you've never seen this software, you got to start somewhere. So, all right. Okay. So let's first talk about map projections. So a map projection, right? A way, you know, the Earth is a elliptical spheroid, I think is the fancy term. So you've got to take a round thing and flatten it out and make it into a two-dimensional surface. I mean, that's the fundamentals of sort of cartography. And it's a really, really important underlying concept with what I'm going to call geospatial data, right? If you look on this slide, here are two examples of map projections. So a concept with map projections is that they make trade-offs in what's being distorted. Because again, if you're taking something round and you're flattening it out, you're going to have to distort the size or the shape or the area or something else, right? And that's just how map projections sort of work. Now, this image right here on the left, the conformal Mercator projection, have you ever seen maps? Does this look familiar? Even if you've never really honestly any care about maps, you've probably seen that, right? And a real famous place you've probably seen it, whether you knew it or not, if you go to Google Maps, which we've all probably, how many of you, raise your hand, have used Google Maps almost every single day? For the most part, or every other, I mean, pretty frequently, at least at a minimum, right? If you ever noticed, if you kind of take Google Maps and zoom all the way on out, well, now they got more fancy, I guess. It now turns into a globe. It used to be back in the day, though, that it was basically a flat two-dimensional representation. They kind of changed it, I guess, a few years ago. But that's what Google Maps used to be. It's what's called a Web Mercator projection, okay? So over at ArcGIS Pro, let's play around a little bit with a map projection. Go ahead and turn off vector, which is called the group layer, and turn off the raster, so you just have OpenStreetMap. And by the way, have any of you ever heard of OpenStreetMap? Anybody know what that is? Someone tell me what OpenStreetMap is, if they've heard of it. Yeah, in the back there? Perfect, an open source version of Google Maps, right. So there's at RET, there's a big effort now on open initiatives and so forth. But yeah, OpenStreetMap is a free, publicly available map of the world that sometimes rivals Google Map in terms of its sort of coverage. So if we go to just OpenStreetMap and just kind of start zooming out, you can see the map kind of looks like this. All right. Anybody know why it looks like that? Just if you take a wild guess. Yeah.
Well, because if you look between the longitude lines, it would kind of be that shape. Because they would meet at the poles.
Yeah, exactly. Right. So what you're seeing here is a very specialized map projection. Because again, remember, map projections distort things and so forth. And it kind of, this particular thing you're seeing here kind of relates with what we're going to talk about in a second called coordinate systems, in particular this one, the Universal Transverse Mercator, right? And so if we want to play around with it, though, if I were to go just to see what map projections look like, if I go right here where it says Map, and then I right-click and go to Properties, and they kind of blur coordinate systems and map projections together. But if I were to go here under where it says Coordinate Systems, right now under the layer, it's set to the one for the image, It's WGS 1984 UTM Zone 43N. Does that mean anything to any of you when you read that? I'm just curious, again, background knowledge or skills. Anybody know what WGS 1984 is? What that is? No? That's what's called a datum. It's a way that they measure the shape of the Earth. So this is like in the world, I think it's World Geodetic System from 1984. And so they determine that this is where things are sort of located on the shape of the Earth. And from there, it's a reference point. And if any of you have taken like civil engineering technology and like surveying and stuff like that, you go way down the rabbit holes of like datums and really measuring things and so forth. But UTM zones then are these kind of things. It's just a way of taking that Mercator projection I just talked about, that, by the way, really stretches out the north and south poles, but then chops the world up into, I believe, 60 zones that can give you really precise measurements inside of a zone, right? So when we look at this one, this part of India is in UTM zone 43 north, meaning that it is it's north of the equator, okay? And again, those kind of details aren't really too relevant, but I just kind of want to make you aware of it. But let's play around with it a little bit. If we were to go and look at geographic coordinate systems and expand that out. And so map projections, there's thousands of them that have been designed for really specific cases. And if you take a class like 382, that class goes more into this kind of stuff. This is just a high level kind of review of this stuff. But if I were to scroll down and go to world, and let's just do WG. I'll just pick one of the 1984s. Here, just do generic WGS 1984. Okay, so that's now the WGS 84, sort of a geographic projection, which means that it's really strictly based on latitude and longitude values. So just take a second and mess around with it. Like even the more familiar ones, if I go back to map, properties, go under projected coordinate systems, and then do world. Let's see, where's Mercator? Yeah, like Mercator world, right? Because we've been talking about that projection. So I went to coordinate systems, projected coordinate systems, world. I selected Mercator world. I hit OK. And now we can see how there's that Mercator projection, right? So it applied all the sort of mathematical transformations to create the view of the world that looks like the Mercator projection. My understanding of the Mercator projection, it was designed in the age of European exploration or conquest, depending on how you look at it, of sort of the New World, because it's very good at preserving, I believe, distances and shapes. So think about it. It's 1600. And you're sailing from Portugal, and you really need good navigation, right? It's life or death, long before GPS. This particular map projection was good for that kind of thing, but because of the trade-offs it makes Greenland look enormous by comparison to the United States or Africa. Like the continent of Africa is hugely different than in terms of its just size than Greenland. But if this is what you've ever looked at, you may think the world looks like this. Did anybody ever play the game Risk growing up? At least in my day, this was the map projection that was used in Risk. Does this look familiar at all? Remember that? Back in my day, like Greenland was this huge thing because little tiny Iceland, have these big epic battles here like going in, but it's just a distortion. It's a map projection, right? And there's all kinds of them. If you were to look at another one, the Robinson. So this is one that preserves the correct size of things, right? So take a look at this projection now. Now you can see Africa is more proper size, right? And so, you know, again, even if you never really work with maps, if you ever start to see maps for things like during election years, wars, in the media, take a look at the map projection used, because just there can be a lot of miscommunication that can happen. My understanding of this particular map projection, this is what National Geographic would use for years to show something at the world scale, like world population. So if there was a color used in every country to show population, this is the kind of map projection they would use. Okay, so ArcGIS Pro is very good at just swapping around whatever projection you need. Okay. Any questions on so far on map projections? Just the idea of it.
Yeah. So I guess for the Michaela,
Yeah. Yeah.
projection, so you said it was like from the old days, right? So how would they go and measure and what project it?
That's a topic that I'm not an expert on. I know the basic idea of a map projection. The old way is like they would take they would literally like put a light inside of a globe, and like the light would shine out, and they would use that to draw the lines. Nowadays, some of you that are way more math savvy than I am, it's basically you use lines of latitude and longitude to define where it's going to go, and you do the mathematical transformations. I'm not doing any clear job of explaining that. I would just encourage you to look that kind of thing up, or how the actual engineering of a map projection. Because for some people, again, like, yeah, you take like like in this picture, well, this is not really define where the meridians are, and then wherever the projection surface is touching the globes, that's where distortions will be least, and as you move away from that, that's when you start get distortions in size and shape and all that kind of stuff. A class like 382 goes more down that road, but take a look if this is something you're interested in. All right, any other questions? No? All right, so let's go back to the PowerPoint then real quick. So yeah, we looked at that, so here's the screen. But how does this relate to things in class? So those of you that might be interested in building a game with Unity using real-world geospatial data, so here's our course roadmap. You can see it. I have it on the ArcGIS Maps for SDK, and then here's a link. They have this idea of global scenes and local scenes, and in that particular tool, the local scene would be like, I'm going to build a simulation or game focused on a neighborhood in a city. Therefore, I have much more precision of like the buildings and everything else. Versus a global scene, I'm going to create a simulation of climate change, how it's affecting the world, global, right? So depending on what you do, you've got to use either Web Mercator with spatial reference WGS84, or a local scene with any projected coordinate system, and so forth, right? So this is where this may come up and bite you if you're not aware of it. So you found a really great data set that's going to work perfect in your game, and you do all the steps, you load it in, you see a blank screen of nothing. Well, that's why you need to understand, at least know that this is a thing you have to deal with when it comes time to it. So that's where map projections relate to, in this case, to that particular topic in the class, okay? Now, again, when I use these slides, it's probably not the only place it will, but this is just a representative example of how these underlying concepts will feed into other things in the class. So again, that's why I have this screen recording, and you may find me like, yeah, I did mention that back in week 1 when we get to week 11 or 12, and all of this is, ancient history where we're at and so forth. So any questions on that? Just how it relates? Again, I'm just showing you can look at the link to learn more about it. So I'll move on then. So coordinate systems in the GIS context are closely related to map projections. So this is just a really brief review. Latitude and longitude. basically they're measurements of the Earth based on angles where you go from the the center of the Earth and you're measuring the angles that go out. So when you say it's 40, in this example, 40 degrees north, that's the angle from the hypothetical center of the Earth for latitude, and then longitude is basically measurements around a circle. And because it's a circle, you have to pick somewhere to start, right? How do you know where to begin? Anybody ever heard of the prime meridian? Does that name ring a bell? What is the prime meridian? Yeah.
Just going off the money. It's the prime meridian is a line height-wise going from the pole one pole to the other.
Yeah. Yeah, the prime meridian is basically like an arbitrarily defined 0 point. So if you're on a circle, like how do you, if you got to measure around the circle, you got to pick somewhere to have the like sort of a datum. And so in the olden days, anybody know what there's this is just a little bar trivia question. Like what's the name? What's the location called where the prime meridian is? Yeah.
Is it Greenwich?
Greenwich, right? Greenwich, yeah, Greenwich, England. Sometimes they talk about Greenwich Mean Time. Everyone heard of that GMT, right? So, back in the old days, Greenwich, England was decided this is where 0 of longitude is going to begin, and everything kind of gets measured from there. And so some of the lingo here is the meridians are the lines of latitude and longitude. Excuse me, meridians are longitude, latitude are parallels. Right? Sometimes if you're into like military history, I think it was in the Korean conflict, like they couldn't go north of the 54th parallel. That's good like military talk, right? They mean latitude. But that's the basics of latitude and longitude, and that's the basis of coordinate systems. So in ArcGIS talk, this coordinate systems that are just based on latitude and longitude are called a geographic coordinate system. And then what ties into that idea of projections, when you take that round surface and you flatten it out, you then get what are called planar coordinates, which are going to be an XY grid, okay? And that's just a different way of measuring where something is. And that's kind of ties back into that, the UTM. So the UTM is an XY grid of coordinates that have special projections that have been developed for every zone to measure. So let's see what that looks like in practice.
Why are the lines not lined everywhere?
Oh, let's see
Like right by like
where this red arrow is.
there and like right by like Sweden or like Norway, whatever it is.
I think that's from distortions in the projection is why it's like that. I don't really know. That's a good observation. I don't know why it's not just a perfectly straight line, but it could be they decided to change it a little bit to make things fit in. Again, this is more like in 382, but like in New York here, like we're right on the boundary, like in Rochester, New York, we're right on the boundary of zone 17 and 18. So like zone 18 sort of mathematically ends and then becomes zone 17. So all they do is just extend it. They just say, okay, we're just going to keep it going because it's too inconvenient to have to like, that's how it always seems to go. You're doing some project and your stuff is right on the boundary of like 2 different maps or 2 different zones. So that's a technical thing I don't know. That's a good observation. I just don't know particularly why that is. I have my hunches has to do with distortions. They wanted to lump certain islands and kind of like time zones. There could be some arbitrary things they say this is how it is. And so in terms of some hands-on then, we already kind of saw this, but if you were to go down here in ArcGIS Pro, you have a bunch of different coordinate systems kind of all ready to go for you. If you click that box right there. So anybody ever heard of decimal degrees? Anybody know what that is? Decimal degrees? Is that a hand raised back there? Yeah, what are decimal degrees? Kinda. What are decimal degrees related to? No? Okay, we'll just back up a little bit. So latitude and longitude are usually, like if you click it, degrees, minutes, and seconds, right? The problem with degrees, minutes, and seconds, they're just not very practical. Like, especially you think about a computing application, like we got to go to 14, let's go to Rochester here, kind of where we are. You know, we're at like Rochester's around like 77 degrees, 45 west, 77 degrees, 35 minutes, 45 seconds. It's just not really practical. So all decimal degrees are just a transformation of degrees, minutes, and seconds into a more straight, I guess, use my computing data terms, a float. Is that would be a floating point, a double? 76 point, you know, the numbers, right? It's just a better way to calculate it. And you're going to find, we're going to see decimal degrees come up pretty much exclusively compared to degrees, minutes, and seconds. It's just a better way to handle coordinates. So if I were to go back over to Google Maps, even just look at the URL. This is how they do it. So Google Maps with an argument of 22.14, blah, 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 comma, negative 14 point, blah, blah, blah. You know, it's decimal degrees. That's how Google Maps does it. Now, I'm zoomed out far on the Earth. Here, I can start plugging some of my research. I do a lot of work in Rwanda. And so if I go to this particular place, it doesn't really matter. You can go anywhere. But if I just were to click and do a sort of what's here, I just clicked somewhere random. Notice it gave me a decimal degree coordinate pair, right? So if it's, I believe if you're west of the prime meridian, you're going to get a negative number. And if you're east of the prime meridian that we just talked about, you'll get a positive number. So if I go, I'll just click over here. Yeah, so this is 16, 88. But if I go again, Greenwich, England, kind of right about there. If I go, oh, here's some trivia. This is where the Titanic sank. In 2019, I did this, I'm going to go off topic here. I did this really cool trip. I took a freighter ship across the Atlantic Ocean, and we were within 100 miles of where the Titanic sank. But look, you know, so that's showing it as degrees, minutes, and seconds. But if I were to click near there it is in decimal degrees. Okay.
So, what is the minute second? What is that? Like, what is that measurement?
It's just a sub measurement of the actual. If you were to look at you'd have, I didn't think to include a graphic showing lines of latitude and longitude. I just kind of whipped this out, but it's basically ways like degrees are the highest level. So like from 0 to 180 or negative, that's like the first level. And then you have basically just sub levels within that to like kind of break it down. So decimal degrees, again in 382 they go over like how to take a degrees, minutes, seconds, and just turn that into a decimal value. There's a simple formula for it. But yeah, it's just basically sub units within the bigger thing. So. So any other so far any questions about the basic idea of coordinate systems? Okay, so really important, it really drives a lot of everything, like an indexing or referencing system of the surface of the Earth. Now again, back to how this relates to things. As one example, we're gonna when we get into like Python and then specifically ArcGIS Pro Python, you're going to have to we're gonna work on like creating the topic that's coming up next. We're going to create spatial data sets in code, and you have to set coordinate systems and spatial references of those data sets. Okay. We're mostly just going to use WGS84, but again, this is an example of some Python code where, if this doesn't mean anything to you, I'll just walk you through it. Like you're setting up your database, you're getting feature classes, and then in this line right here, the spatial reference, you're using a Python library to get the coordinate system and spatial reference of a data set and going from there. So if it doesn't, sometimes data sets don't have a spatial reference or coordinate system set to them, so you can do that in code, okay? So that's where this kind of stuff is gonna come up. It also really relates back to even this slide. Projected coordinate systems, Web Mercator, Um, that could be important, say in a game, you need to use certain coordinates to place things. In fact, when we talk about one of the example games, it's called Jack Votalic. I haven't gotten around to posting it, but I'm going to show you guys a game that was built by some RET students on co-op working with the Army Cybersecurity Institute, and they used Georgia, the state of Georgia as an example, and they had to use real-world coordinates to place objects in the game because the game was based on a real-world coordinate space, and so that's where kind of coordinate systems can come into play here. Okay, so again, if you've never thought of this or seen this in a spatial context, just wanted to, this is where these ideas will come up. Okay. All right, let's move on then to the next thing. Data models, raster and vector. This is probably one of the most fundamental things of GIS in general. If you've taken a GIS class already and they didn't talk about raster and vector, you should ask for your money back, because this is like, raise your hand if you've heard of raster and vector in GIS. A couple of you, so you're probably familiar with this. But the basic idea is, with a data model in general, if I said a data model, does that mean anything to you guys? I mean, even outside of GIS, have you ever heard that term? What's a data model? You've seen that.
It's like a template. Some sort.
Yeah, a template. Yeah. Yeah. Anybody ever take like a database class? Yeah. Did you talk about data models?
Yeah, so like creating like a data set of some sort.
Yeah. So again, let's even back up. What's a model? What if you had somebody ask somebody like, "What's a model?" What would you describe that?
Some kind of abstraction that conveys a physical concept.
Yeah, perfect. Yeah, exactly. Models are an abstraction, a representation of something in the world. So like, maybe you used to or still do, you play with model trains, model airplanes. I mean, it'd be super cool to own your own airplane, but barring that, you have to get a model one, or So a GIS data model is a representation of something in the real world that's been abstracted down, and really in the computing world, really reduced to binary ones and zeros, right? So if I take something like, this is actually not far from where I live. This was flooding that happened in Lake Ontario. If that's what I have to show in the computer, I have to make a map to give to a decision maker about what to do with all of this. How do I take that? How do I take a tree, the water, the bushes, and put that all into a map? I have to have a data model, right? So I have to go from that and turn it into perhaps a polygon, a line, or a point. And that's the idea of abstracting things kind of down. So the two core ideas are, there's two kinds, raster and vector. So let's first talk about raster. Raster is a data model, and this is like good, like, I don't really do this kind of examination, but like, this is good like midterm exam questions in some other classes. The raster data model is a grid of cells that is used to show continuous phenomena where there are no discrete boundaries, okay? So when I say no, continuous and no discrete boundaries, terrain, there's always like a surface of the earth somewhere. It never ends. There's always temperature. It doesn't just like stop. Raster is also very, it's basically the same idea like we all have phones with cameras, and maybe some of you said you're really into photography. The resolution of your phone, the pixels, right? That's the big selling point of the newest and greatest phone every year. The new iPhone, Android, whatever it is, XYZ, more pixels to get more fineness of resolution. It's that same idea in GIS world, okay? So if we go back over to ArcGIS Pro to try to keep a little interactive for you here, if I go back over to raster, and by the way, here's a little trick. If you're zoomed out far away, I'm going to right-click on raster and go to zoom to layer. And it might look a little weird right now. It's kind of, see how it's distorted with the projection. But rasters, this is a TIF, a TIFF image. Rasters are often used for imagery, okay? We don't have anybody from imaging science in the class, but if you ever to go to like the Center for Imaging Science, this is what they have a whole huge part of RET that's focused, I'm grossly oversimplifying what they do, but they're focused on raster imagery. satellites, drones, they capture images, and then they go in there. So if you were to really zoom right into this thing, you can, I don't know if you can really see the image. Yeah, you can't really see the pic. Well, you can kind of see a little bit. But a continuous representation of an image. Now, as a cool thing you can do with rasters like this, this particular one comes from what's called Landsat. Anybody ever heard of Landsat? Yeah, what's Landsat?
Isn't it a type of, I guess, satellite? It's like a type of satellite that takes a image around the world, something like that.
Yeah.
Like a satellite image.
Yep, absolutely. Landsat. Landsat is a program, I believe, by NASA. Yeah. It's one of the flagship sort of science projects of NASA. So there's basically the U.S. government has, well, they're up to the Landsat 9 mission. It's constantly going around collecting imagery of the Earth. And this goes down the road of remote sensing and electromagnetic spectrum and different color bands. But if any of you are ever interested in projects related to like climate change, urban growth, Landsat is the premier free and open source data that the whole world uses. Things that are created by the US federal government by law have to be made publicly available. And so that's why a lot of people use it. And so, for example, if you were to go over to this and we look at this slide, I didn't talk about spatial resolution. With raster imagery, especially something like Landsat, they have different bands, which are different parts of light and energy that have been collected by the satellite sensor, and you can change around the way the image looks. So like if you want to look at the color infrared, the vegetation, 543, what that means is if I go back over to the ArcGIS Pro, I right click and do symbology, I can manipulate the red, green, and blue color channels. I think I said 543, so I'm gonna make red the 5 channel, 4, and 3 is already there. So this shows you where there's healthy vegetation. Now, I've never been there, but Mumbai, India is a huge urban environment. So there may not be a lot of vegetation per se in there. I mean, there's probably parks in various areas, but that shows you how with a raster showing a continuous surface, and in this particular case, you can manipulate the color bands to show what's in the image. And that can be, you could do that programmatically with code, or you might do that in a simulation or a game and so forth. So that's raster. Any questions on that about raster? Okay, so again, continuous surface, grid of cells, grid of cells continues, no discrete boundaries, okay? Oh, and I forgot, I did kind of mention the spatial resolution. This is exactly just like your phone. The number of pixels determines how much sort of detail you're going to get. And so there's different kinds of data sources that are out there that have different kinds of resolution. And again, this may not really be germane to anything that you're doing, but it's important just to mention it. This may come up. So let's move on then to the next topic, which is vector. So we had raster, which was continuous, no discrete boundaries, grids. Vector, which you've probably heard about in other contexts. So those are based on vertices for discrete things, right? And that's the basic idea here are points, lines, and polygons. And that's kind of the abstraction I talked about here. Like you might represent where a tree is located as a point, right? And you might show a road as a line. And you might show the area of a flood as a polygon, okay? Have you guys ever heard of the idea of vector outside of GIS? Raise your hand if you've heard of vector before. How have you guys heard of vector before this class? Math class? Okay, yeah. Any other? Yeah.
Vector graphics.
Vector graphics, right? Well, SVG, I think, is a good example of that. Anything else or? Yeah, and CAD, absolutely. Yep. Absolutely. So it's the same kind of idea that you've heard about in math, in vector graphics, in CAD software. It's right there in GIS too. So if we turn off the raster folder and just look at vector, here it all is, right? So like, oh, I forgot to update the points. I didn't put any points in there. I'm sorry. Well, you guys get the idea. Like here are the railroads, which are lines. Here are the boundary of the city, right? Now, a little thing too, if you click on, like if you just go to this polygon, boundary polygon, if I click on that, it can tell me things about it. Now, you don't have to do this, but just to show you quickly, if I were to go to Edit, Modify, whoop, and do Edit Vertices, okay, there's the vector. So vector is basically just a series of vertices, these little green things here. They're just, if you were to like learn about the internal plumbing sort of how these data sets work, all they are is just a massive collection of XY point pairs that define a coordinate of where the vertex is. So think about like, you know, like trace, like, you know, and the more vertices you have, the more detail you have. And if you ever, a class like 384, which gets more really all focused on really driving ArcGIS Pro, but that's where you can get into like, you know, you can mess around with the vertices, you know. But that shows you the idea of vector, right? It's just a bunch of, in fact, if you look right here, here are all the vertices with their coordinate pairs. If I did like zoom to, you know, it just, you know, and so basically the software then reads in all of those coordinates and renders them out into the shape you see, in this case, a polygon. Polygons are the most sort of not complex per se, because there's just a lot of coordinate pairs. Points are the most simple. And later in the semester, we're going to do things like read coordinate pairs from a CSV file and plug those into creating a vector data set. Okay, so now we've been introduced to the idea of vector, and you at least have seen it. So any questions then about raster and vector? No? Because again, this is super core, excuse me, super core kind of stuff. You know what? Just to play it safe here. All right, great. We're gonna just plug the battery in. All right. Just for sake of time, yeah, real quick. I want to make sure to cover everything and make sure you guys are clear on what to do for next week. We go to what, 9:15 in this class? Yeah. All right. Vector data and attributes. Let's go back to ArcGIS Pro real quick. Let's go to like Mumbai buildings. Let's just take a look at that one. If you were to go to Mumbai buildings, kind of zoom down in there and like, you know, these little, in my case, they are these like blue polygon. So now we can start using our lingo. They're blue vector polygons, right? If I were to go and right click on the layer Mumbai buildings and do attribute table, okay, this is really core GIS stuff too. So every vector shape has associated with it data attributes, right? So if I go to the attribute table, if you look at these columns, the shape, polygon, right? That's, like I said, that's all those internal coordinates of the vertices. You don't really see that. It just says polygon. If you programmatically can go in there, you can actually get at all those vertices directly, but then you just have stuff, what they call attributes associated with it. So if let's go to the very first one, and right click on it and do a zoom to. So see how now my screen now, there's like a blue polygon with like a blue outline around it, right? that is this record in this table, that shape with those attributes, okay? And that is one of the most, again, really one of the most core things of vector data sets, that they have attributes attached with them. And that's really the power of GIS in general. Anything that you can put into a data model, I want to model from practical things like telephone poles to locations of trees or whatever, and then I want to describe something about that. So the shape and what it is just one attribute along with other things. So in this case, a building. I have the footprint of the building, that's the shape, but then the name of the building or the type of the building, anything that you want to put into your data model, right? And we'll see that come up in class when we do programmatically creating data sets, because we'll take data and attributes and plug that in. So again, I just wanted to introduce that concept if you've never seen this kind of stuff before. So how do data models relate to things in class? I actually had a hard time even thinking of one way to think of it. It relates to everything in this class, because everything in GIS is fundamentally driven by data, right? We're going to be ingesting you'll learn more about what are called shape files. We're going to be reading table CSV data. I thought of this one, we're going to do this polygon extrusion. When we talk about 3D geospatial data, we're going to take two-dimensional vector polygons, and there's tools you can use to read the attribute table to extrude them out automatically. And then from there, we can make some kind of rough prototype 3D data sets that we could then plug into Unity, right? So data models, again, like I said, are all over the place in this class, but that's just one concrete example I can think of. We'll do polygon extrusion, okay? All right, let me move on with a few more things. Basic mapping concepts real quick then. A reference map. Anybody ever heard of this idea? Reference versus a thematic map? You guys ever heard these terms before? No. Anybody know what you're seeing on the screen right here? It is right. What kind of map is it? Anybody recognize like where it comes from?
Geological survey.
Yeah, very good. Yeah. This is a U.S. Geological Survey map. I believe it's called the West Henrietta Quad, and RAT is in there somewhere. And this is what they call a reference map. So the idea here, the basic idea, there's a lot of things shown, but nothing very specific. It's just a general reference of the world. You could maybe argue that Google Maps is basically a reference map. It's not showing you anything. Google Maps is showing me where the river is. It's showing me the roads. It's putting all these kind of things all over it. There's some commercial interest in showing all this. But it's not the same as the other kind of map type, which is a thematic map, where you have a data variable. You have something very specific that's being shown. So in this case, world population, right? The populations of China and India are significantly more than other parts of the world. It's a thematic, there's a theme to it with data being shown, right? Google Maps doesn't do that. Google Maps just shows you where things are. It's not giving you any kind of particular message. It's basically a reference map of the world, and that's why it's helpful. I need to know where Chick-fil-A is, I don't necessarily need to know like epidemic outbreak and so forth. Now, Google Maps can show thematic information. So often what you do is you use a reference map that you then put thematic information on top of, right? I can't really see any thematic stuff. Sometimes, you guys ever notice that? Sometimes, like when COVID was going strong, like Google Maps would show you COVID cases. Anybody remember that? Seeing that? That would be an example of a thematic map of COVID cases was put on top of a reference map. In this case with Google was the tools to implement all that. And so in ArcGIS Pro, at a minimum, I can show you with your base map, this back to OpenStreetMap, that is essentially all of these base maps are reference maps, right? They show you what's there. So OpenStreetMap is a great example of a reference map. Now, if you go take a look over here under the menu Map and then Base Map, you get all kinds of different kinds of reference maps. They call them base maps, but the proper, I mean, maybe old school cartography term are reference maps. So like, for example, a really good one to use is the light gray canvas. Light gray canvas is really good for the combination of a reference map with a thematic map, because there's something called figure ground relationships. So if you were to do something like the Mumbai land use, and I were to right click and look at its attribute table, and I want to do what you might call it a qualitative thematic map. I want to make each color of these polygons based on the value of the feature class value. So if I were to go to Mumbai land use, right click and do symbology, and then I'm going to do unique values, and the field is going to be F class. Okay, so that's now a thematic map. The theme here is the type of land use, right? And that is represented with different what you call visual variables, which I think I'm going to have to kind of hurry up and talk about that because I'm kind of running out of time here. But so that's my reference map is the light gray canvas. That just shows me what's there. And then my thematic map, in this case, are the Mumbai land use areas shown with a color, right? And so that's the idea of those mapping concepts being played out in ArcGIS Pro. I'm not using numerical information. That's a whole nother topic, like different sizes and shapes for different numerical values, okay? So basic mapping concepts, you're going to see this come up a lot in reference maps or base maps in both the SDK for Unity and also the Esri JavaScript API. And because you can change the base map layers around. So those of you interested in JavaScript coding, maybe take a look at some of these links that I've put here just to start thinking about that. And then real quick, cartography ideas. I already kind of mentioned it. Let's just get right here to visual variables. Anybody ever heard the idea of visual variables? Has this ever come up in like a design class? No? Okay. So real quick, visual variables is the idea when you have data and you want to visually encode it somehow, right? So using this graphic here, like one of the visual variables is size. So the smaller the circle, the less the quantity of something, right? So in this case, the number of people in a city, like small circle, medium, and big, based on the numerical value. Now, what I just showed you guys with the example over here, right? I did this. I used color hue for qualitative, and in this case, I used land use type. In my graphic here, I'm showing hazard types, but you use a different color to represent a different qualitative value. And do you guys know what I mean by qualitative and quantitative? What's qualitative? What does that mean?
Qualitative means you're like describing the aspects of it. And it's easier to say it's different from quantitative, which is about numbers and quantities.
Yeah. So qualitative is a non-numerical representation. You know, yellow, green, red, and blue. They're just random, just colors that have been assigned to something, but there's no significance of the use of that color, right? So land use, right? A park is green, the beach is yellow, water is blue. There's no numerical significance versus, the population of a city. There's a big difference between Rochester, New York's population and New York City's population, right? So using a different color hue wouldn't really work in that case, depending on what you're trying to do. Again, that's a topic. This is a huge topic that, you know, other classes go more deep into this. I'm just introducing it to you here today so we have some background. And where are you going to see that in the class? I already kind of showed you a little bit of this, really, in some of those projects. The student from last year that did COVID cases, right? So thematic mapping of COVID is a great use of cartography ideas. The more COVID cases, the bigger the size of the thing you're showing, or the number of people recovered could be a different color. And so the Esri JavaScript API in particular can do this kind of stuff very well. And you know, more than I had time to talk about today, with animation, which is its own kind of visual variable, colors and shapes and sizes and so forth. So that's where you're going to see cartography ideas come up later in the class. Okay, so at least we've covered them today. Okay. I apologize if I went a little fast at the end there. Any questions on what I just talked about, mapping concepts and cartography concepts? No? I mean, hope you found that interesting. So again, just to summarize, so we covered map projections, coordinate systems, which are two closely related things. You're going to see that come up when you start to try to plug data into some of these various tools. That data in turn is going to come from two basic kinds of data models or representations of the Earth, or representations of things in the real world, raster and vector. Raster is used for continuous things. Vector is used for discrete things, points, lines, and polygons. And then we also talked about some basic mapping concepts. Reference maps are really base maps, and also thematic maps. And thematic maps then relate to how you're going to visually encode data. Looks like my screen recording worked well, so refer back to this lecture as we go further into specific tools to kind of come back to these ideas and so forth. Okay. Hi, this is Brian Tomaszewski. If you enjoyed this video, be sure to like, comment, and share this video. Also, please consider subscribing to this channel and clicking the notification icon to stay up to date on new videos from this channel. Thanks for watching.